This is a video that goes through an introduction to HEC HMS, which is Lab 7. I'll be going through this handout that is a pretty good step-by-step procedure even on its own without a video, but the video will help you find things as you're going through. And I'm going to go as fast as I can through the video. You can pause it and look back if you need to. So we're going to go through step by step. We've got HEC HMS here. So the first step is we're going to start a new project. So file, new, name of my project is going to be Lab 7, and description is we're looking at the Fox Creek watershed. Okay. We're going to be doing U.S. customary units. So we create that. Okay, so let's see. Next step. 3 components must be defined to run the hydrologic model. The basin model, the meteorological model, and the control specifications. So we're going to create a new basin and components. Basin model manager. We can just call it basin 1. And then you see it pops up here under my project. If I click it, I can see here's basin 1. Alright, so now at this point I want to draw out this basin according to the figure that's in the lab. So if I go down here, this is the figure. It's trying to represent the watershed. So we've got subbasin 1, which is down here, 2, 3, and 4. At the base of subbasin 4, we have this detention pond. Subbasin 2 and 3, you can see these little drainages that come out of those that both join here at this junction. Those drainages go through those subbasins, and then we have connecting from the detention pond to this junction, we have this thing called reach 2, and then from this junction, reach 1, down to the outlet of the entire watershed. So everything's kind of flowing down this way. Alright, so we're going to try to represent that in HEC HMS. So I'm going to go back here, and I want to add the model elements. So up here you can see I can create subbasins, reaches, reservoirs, junctions, diversions, sources, and sinks. Okay, so the first thing I'm going to do is I'm going to create some subbasins. I'm going to click on that, and I'm going to make 4 of them. First, subbasin 1, subbasin 2, subbasin 3, and subbasin 4. And then I'm going to need this detention pond reservoir at the base of subbasin 4, so I'm going to put that one in right there. And then we'll need a couple reaches as well. So if we click on the reach, here we can connect different things. So the reach 1, oh, we need a junction first. So let's put a junction here. So before we create the reaches, we can connect these. If we don't have any sort of travel time, like a reach of a river in between the elements. So for example, subbasin 2 drains directly into junction 1. And so we can click on subbasin 2. If we right click on it, there's this connect downstream option. And hit connect downstream and then click on the junction, and it'll connect it with this narrow line that shows that subbasin 2 empties directly into junction 1. Alternatively, I can look at let's see, where is it? Yeah. So here's subbasin 3. There's an option under the subbasin tab over here of downstream. If I click on junction 1, it'll just connect it for me. And then subbasin 4 connects downstream to reservoir 1. But now between reservoir 1 and junction 1, between junction 1 and subbasin 1, we've got reaches. So we've got to go to the reach creation tool. We're going to click first on junction 1 and go down to subbasin 1, and that's reach 1. We got to make sure that we actually connected them. If I click on the reach, you can see downstream it has none. So we want to make sure that that changes to subbasin 1, which it's not letting me do. Oh, I know why. So subbasins cannot be downstream of anything. That's why you can just see an arrow going out. So rain comes in, and then we have flow going out. So at the bottom of our model, we have to create a sink. A sink allows stuff to come in and kind of exit the model. So everything that goes in there just stays out of the model from then on. So now when I click on my reach, I actually want the reach to go to the sink. So the downstream I connect to sink. And then subbasin 1 is also going to drain directly to the sink. Now I'm going to go back to my reach creation tool and do one from reservoir 1 to junction 1. Create that one. And then I want to make sure downstream it's connecting to junction 1. Should be. Okay, so I can see if I drag this around that this reach is not connected here and this one is not connected there. That is not good. So we want, if we click on reservoir 1, there's a downstream option for that. I want to connect that to the reach I just drew, which is reach 2. And then on junction 1, it's downstream. I want to connect to reach 1. Okay, so now I've got the layout of all the things correct to mimic this diagram right here. So that is through step 4 in the handout. Now I'm on to step 5. I can use the parameters menu to open tabular data editors, or I can click on an element and edit it down here. So the next step is I want to enter data. Here's my subbasin characteristics. I also have some additional information down here on the reaches and the detention pond. So subbasin 1, 2, 3, 4, how big they are, the time of concentration, what kind of landscape they are, the soil group, and the base flow. I want to enter this data into the model for each of those subbasins. So there's different ways to do it. If I click on like subbasin 1, and I click through these tabs over here, I can get to the different options. So, for example, subbasin 1 has an area in square miles of 2.12. Anything that has a little red asterisk next to it is something that's required in order for you to run the model. We also need to make sure that we set these correctly down here. So you can see there's different methods. Loss method has to do with the infiltration. So green amped, we talked about a little bit in class. There's some other options. Initial and consonant would be something like the phi index or Horton infiltration. So we want to use, for our loss method, we want to use the SCS curve number. Yep. And for the transform method, we want to use SCS unit hydrograph. You can see here's some other unit hydrograph options: Clark, Snyder. Use that. So that's where it says to use those in the handout itself. And then base flow method. So we talked early on about base flow, and when you have a hydrograph, how you sort of connect or take out the base flow from that hydrograph to get the storm hydrograph. So there's different options for that. We have in our table, on the bottom it says base flow 0. So in our watershed there is no base flow prior to the storm event or after. Right? So we're just going to have base flow none. Right? Now that I've set these two methods correctly, if I go to loss, I'll see that I have initial abstraction, curve number, and percent impervious. So at this point, I need to enter a curve number. And the curve number, remember, we have talked about in class. We know what the soil cover is and the soil group. So we have to look these up in the tables in our book now. So you're going to look those up in table 8.7.3. For subbasin 1, we're urban developed quarter-acre lots, and they're 38% impervious, soil group B. So I looked that up in the table on page 305, and the curve number is 75. So we go back here, curve number, enter 75. My percent impervious was 38 for that. No initial abstraction. I go to the transform. Okay, so we're going to use this graph type standard PRF 8484. What's our lag time? So there's a note on here on the handout that the SCS lag time is 0.6 times the time of concentration. So in subbasin 1, my time of concentration is 3 hours. So my lag is 0.6 times 3 hours, which is 1.8 hours. When I go back here, I should note that the lag time here is in minutes. So 1.8 hours times 60 minutes is 108 minutes. And then I've got nothing for options. So it's a good idea when you're doing modeling to just, again, attention to detail is really important, to click on each element and kind of click through all the options and make sure that you've set everything correctly in every element. So I've just done subbasin 1, but I could also go up to parameters, and if I go to like subbasin area, all elements, here I can actually just enter in the areas for all the subbasins. So I can go back to my table. I already entered the 2.12 for subbasin 1. 2 is 3.04. 3 is 1.96. And 4 is 1.60. Apply that. Now I can go to parameters and I can go to loss. Let's see, did it default the others? No, it didn't. So I might need to, let's check here. Yeah, so it might be easiest to just click through the subbasins and change these for each of the 4 subbasins before we move on. Okay, so now when I go up to parameters and I go to like the loss, SCS curve number, pick all the elements, here's where I can put in my curve numbers for the other subbasins. So I'm going to pause this and do that real quick. Okay, so I've got those entered in now. You can see that this was the undeveloped grassy forest. There's no impervious area in a forest. And then the other two were 50-50 developed and forest. So I split the difference on the curve number and on the impervious area. That was the loss. Let's see, transform, SCS unit hydrograph. I've got my lag times I need to enter in now. So again, 0.6 times the time of concentration, and then put into minutes. So 5 times 0.6 times 60. We've got, for subbasin 2, we've got 180. For subbasin 3, 4 times 0.6 times 60, we've got 144. And for subbasin 4, we also have 144. Alright, base flow, it might be easiest to just click through each one. 1 has none, 2, oops, none, 3, none, and 4, none. Alright, so what do we have left here? We've done that. We did that. I think we're all set on the subbasins. Okay. So now we can turn our attention to the reaches. We've got this guy, which is reach 1, and this one, which is reach 2. These represent like a river or a stream that actually has some travel time to it, so it takes some time for water to get from junction 1 to sink 1, for example. So it says the 2 reaches of the main branch have lengths of 8,200 feet, so reach 1, 8,200 feet, and the velocity is going to assume to be 2.5 feet per second. So when I go over here, and I go to routing, and I say, what is my lag? That's how much time it takes to get from junction 1 to sink 1. So if I have 8,200 feet moving at 2.5 feet per second, it's going to take 3,280 seconds divided by 60. I have a lag time of 54.7 minutes. And here I have 7,200 feet divided by 2.5 feet per second. I have 2,880 seconds, which is 48 minutes. Okay. Last, we have the detention pond, the reservoir. So on this guy, we need to enter in this data, which is a storage-discharge relationship. What that information is saying here is saying when my detention basin is empty, has no storage in it, it has no discharge. When there's 2 acre-feet of water in it, its discharge is 40 CFS. And when there's 200 acre-feet, its discharge is 160 CFS. So the higher the storage goes, the higher the outflow. And then the system, the software will interpolate between these values. Okay. So I'm going to use components paired data manage to create this table. Then I can apply it to the reservoir. So I'll go to components, paired data manager. I want a storage discharge function. There's other options, but I want storage discharge. I want a new one. Let's call it table 1. That adds it to this area up here. So here's my table 1, and here's the table that I can enter. So my storage is 0 to 200. My discharge is 0, 40, and 160. And then that's now table 1. I can go now to reservoir 1, and I can say my storage method is storage discharge. What's the function? If I make this a little bit bigger, I can see a little thing here where I can create the table, or I can just assign now table 1 as the function for this reservoir. Alright. So I think I'm now to the end of step 5. I've created all of my basin geometry, and so this is representing a physical watershed. The next step will be to create the storm event. So, but first I'm going to save my data, save my file. I want to model the watershed under an SCS Type 2 rainfall pattern. So I'm going to go to Components, Meteorological Model Manager, and make a new one. Just call it Met1. Shows up now up here. Here's my Met1. So my precipitation, I can specify an actual storm hyetograph, or I can use a hypothetical storm. I think that's right. Oh yeah, okay. So when I created the hypothetical storm, it made a new one up here under the meteorological model. So now when I click on the hypothetical storm, I can pick my SCS type. So this goes back to the precipitation lecture. We saw a map of the US with different regions and different types of storms. And these different types of storms show sort of what is the storm intensity over the duration of the storm look like. So in the Midwest, for example, you have these convective events, high intensity, shorter duration kind of things, where you see this steep ramp up of the intensity and then a drop off. Whereas in the West, we see these slower moving frontal patterns that last a longer time, and so we have more of a gradual increase of the intensity over the duration of the storm. Here we're modeling the Midwest, so we're using the Type 2. Our area is in Type 1A if we were doing Oregon, but Fox Creek is in the Midwest, believe it or not. So Type 2, and then we're going to assume 5 inches of total precipitation, which was a 50-year, 24-hour storm event for that area. Okay, so that's all I need to do in the meteorological model. Now I just need to define the actual parameters for what I want to run in terms of the time and everything. So I'm going to go to Components, and I want to do a Control Specifications Manager and hit New. And it shows up over here. And so I just want to simulate storm here. So I have to specify a start date and a start time, an end date and an end time, and then the time interval, so how frequently it runs its calculations and shows me output. This little note here on step 9 in the lab handout, the time interval is the unit hydrograph storm duration. Its value should be less than 30% of the lag time for any subbasin. So the smallest lag time of any subbasin is 1, which was 108 minutes. If I do 30% of 108 minutes, I get 32.4 minutes. And so the 15 minutes that's there should work. Keep in mind that when it says that this is the time duration for any unit hydrograph, or for the unit hydrograph, this is essentially whatever the shortest, or whatever the model interval is, that's what it sets the unit hydrograph for, because it's going to apply that unit hydrograph through use of like the S-curve method and that other method of kind of lagging the unit hydrograph and summing the different values for a different storm hyetograph, essentially. But all it means is we just need to have it short enough that we can do that accurately. If it's too long, if the unit hydrograph starts too long, then we can't kind of use it in a way that will accurately simulate what's happening throughout our watershed. So for our start date, it doesn't really matter, but it gives you the format here. I'm going to say I want to simulate day 1 of January, we'll say 2015. And the end date, I can't remember, but I think it has to be a certain time after. I'm going to specify it for, I think you have to have like at least 25 hours or something. So we're going to say January 3rd. And our start time here, I think we can do this as midnight, and our end time on this date as midnight. We'll see what happens when we try to run that. This is running for 2 days. That was step 9. And then I'm going to go to step 10, use Compute Simulation Run Manager. So go to Compute Simulation Run Manager, make a new one. We'll call it Run 1. And it's going to run Basin 1 with Meteorological Model 1 with Control Specifications 1. Where did it go? Oh. Where is my option here? Run the simulation by pressing Compute. Where did it go? Oh, right. Okay. So this is the components tab up here. If I hit the Compute tab, under my simulation runs, I see Run 1 right now, right there. And this is where it's matching those 3 things together. So if I right click on that and hit Compute, gave me an error. It said Meteorological Model Met 1 is not set up to work with Basin Model Basin 1. Why not? Let me try to figure this out. Okay, so I had a little error. I forgot to do one thing. Go back to, in the Components tab, you go down to Met 1, Meteorological Model. There's this other tab, Basins. And so when it says Basin Model includes subbasins, I need to change that to yes. And now it should work. So we're going to go back to Compute and hit it, and it runs. And now if I want to view the results, I can just hit the Results tab and make this one big and look at Run 1. And now I have a bunch of results to look at. One thing I can look at is the Global Summary, where it'll show me the peak discharge out of each element of my model. And so it's peak discharges and what the total volume of runoff in inches from it was, or I can change to acre feet, and it can show me what the amount of runoff in acre feet from that element was as well. I can look at hydrographs. So if I want to look at the hydrograph for the whole basin, I'm going to look at it for the sink, which is at the base. So if I click on sink, I can look at graph. And now I'm seeing for that 2-day period, here's the storm happens and then takes a while for everything to lag through. This is the total sink 1 outflow. Some of that comes from via reach 1 into the sink, which is this line right here. And then some of it comes from subbasin 1 itself directly into the sink, which is this one right here. So this one's, you can see the peak is earlier on because it's just directly going from subbasin 1 into the sink, whereas the stuff from reach 1 is lagged a little bit because that's draining kind of the rest of this watershed and taking a longer time to get down there. I can look at the summary table for the sink. So this is saying the peak discharge. So up here, the peak of this hydrograph was 1,467 CFS. And so if I was designing like a culvert or something down here, or some sort of drainage facility, that for this storm event, which was a pretty big one, 50-year, 24-hour storm event, I'd need to design it for this flow rate. And if it could accommodate that flow rate, it could accommodate lower flow rates. So you can experiment around by looking at different pieces and parts of the basin, or looking at the results. And so the deliverable is to look at a global summary table, which is this one. I wanted you to look at the reservoir 1, a graph of that. So for reservoir 1, you can see the inflow going like this. The outflow looks like this. So one of the goals of a detention basin or a reservoir is to take this like flashy peak inflow and then to smooth it out, to lower it a lot, right? This is, you've probably heard from flattening the curve lately, right? With the whole COVID-19 pandemic. This is what we're trying to do, right? We've got so much coming in. We don't want this high amount. We want a detention pond so we can flatten that curve, lower the peak, and what the reach 2 below it sees is its peak outflow is 100 CFS instead of up here over 400 CFS. A graph of the sink at the basin outlet, and so I want you to include the deliverables. Just make like a Word file or a Google Doc or a PDF somehow and put those output in there, and submit those as proof that you went through this exercise. That's all I'm looking for at this point. Okay, so good luck, and let me know if you have any questions.